Hello, MIT IAP students. I'm very excited to be teaching you about scraping. This is going to be the scraping primer where we'll talk about both theory and practice. I'll try to make the theory quick so that we can get into some hands-on things. The ultimate goal is I want you to have a good understanding of fundamentally what's happening, and then you can build on top as much AI and LLM usage as you'd like once you understand the fundamentals. All right, so why scrape? Well, someone has desirable information, but they're not making it directly available or conveniently available. So somewhere there's a database typically, and it has things like products and the product price, the amount they have in stores, descriptions, all kinds of information like that would be an example of something you might want to scrape. Or for instance, maybe you want to scrape news items and comments that are going along with it. So like a Twitter feed or something like that. Or what's on the front page of Hacker News right now? What's everyone talking about? What's everybody thinking about? So we have data. It's tantalizingly close because whenever you see something and it's rendered in a UI, that means you are getting this data. It may be spread across a page or it may be in multiple different locations. But the bottom line is you are being fed this data through your browser or through an application. What we want to do is we want to bring it together into a form that's convenient to use. So why don't they make this generally available? I came up with 3 reasons, but you can probably come up with many, many more. So competitive reasons, for example. So someone like Target may not want to just make their entire catalog easily available to be seen by competitors like Walmart, for instance, because that could have an effect on how they price. They could price more competitively as a result. So they don't just make an API, which is what we would ideally have. A lack of developers is another reason. So sometimes internally, teams will get up the basic UI that's needed and they won't do anything more, and they don't want to expose whatever internal APIs they may have because that can actually be a lot of work. It's much easier to keep that all internal where you don't potentially leak sensitive things. And then finally, and again, not exhaustive, but my final example would be when people don't realize the data they have is valuable, so they weren't selling it. And there's a really good recent example, which is LLM training. We'll talk about that in just a bit. Some of these cases you might notice seem a bit adversarial. The people that have the data aren't exposing it, and they aren't exposing it for reasons that make it seem like maybe they don't want to expose it. We'll get into that. We'll talk about the legal implications and more. So the bottom line is we want to extract the data and possibly take some action or store it for aggregating statistics. So my first example is competitor price analysis. This is already done quite a bit in person. You'll have these people called mystery shoppers or secret shoppers, and they go in and they conduct market research by just being normal enough looking consumers who walk through aisles, who make notes on what, for example, a video game is selling for, and then as a result, you can do a better pricing in the end. Because you have to remember, all of these retailers, they work in a very competitive space, and so they know what their own costs are, but they don't necessarily know what their competitors' costs are. They don't know how well they're doing in terms of negotiations with their suppliers. So if they find that maybe consistently M&Ms are much cheaper for Walmart, well, Target might understand then that the Mars Corporation is pushing aggressive pricing on them if they have a sense of the trends of all their competitors. So this is very valuable potential data. Another example would be checking stock levels. This could be, again, it could be something like hedge funds using it as a data point. So how well are holiday sales going? Are things selling out? Are they not? And then if you see that things tend to be selling out and you expect a really good quarter, maybe then you take a position, a positive bullish position in some of the names. Or if you see that someone else is not selling out at all while everyone else seems to be, you might say, hey, this company seems to be struggling, let's short them. So it's an interesting data point that other people could be interested in using. It would not be exposed, by the retailers just because this is material information in between the reporting sessions that the SEC mandates. So it would be like very conflicting to try to expose this and sell this or put it out with an API. Another example, kind of an abusive example, but you can imagine better uses, is if you wanted to get a PlayStation 5, a pair of Yeezys, etc. There are these things called sneaker bots, and more generally just purchasing bots. They tend to be used by scalpers, but really all they're doing is they're sitting there and they're hitting F5, which is something, F5 is refresh in the browser, which is something that you could also be doing manually. So if you wanted to get one of these hot, elusive items, which, especially when there were supply chain issues during COVID, there was a lot of shortages. And so this would be maybe your only way to get said item would be to have a script that's running, that's always checking inventory levels, and then throws it in the cart as soon as it becomes available. I would obviously encourage you, don't be like these people here that are just hoarding things, kind of asshole-ish behavior, but this is another usage. Finally, we talked about ML training. So on the left, we have the DALL-E model, it's a text-to-image model. And the way this was trained was they scraped the entire internet and they looked at images and their alt text. And based off of that, they got a sense of this text corresponds to this image. And so when we're given this text, we know that we should produce images that look somewhat like this. So here we have some cute teddy bears. A lot of this ML training and kind of this vacuuming of the internet, it happened before there was a broad understanding of how valuable this was going to be. And so as a result, you have companies like Reddit who recently struck a licensing deal with Google in order to take human posts and allow them for training. And you're also seeing lawsuits over this. And it's a big hot topic issue because a lot of people, a lot of companies, they didn't know that their data was being scraped and trained on. Okay, so another adversarial example. So let's get into the legality of this. Number one, none of us are lawyers at Sunday. I'm not a lawyer. I'm a software engineer. Scraping, in my understanding, is kind of a legally gray area. It's a lot like fair use in that the laws kind of depend on the judge and the scope of what you're doing, and you can't really get hard and fast answers in terms of what's allowed. So here's what I mean in terms of fair use. If you've ever seen reaction channels, what they'll do on YouTube is they take a video, it might be a 30-minute video, and they watch it. They put their face in the corner, and they might occasionally say something or pause the video or make facial reaction. But essentially what they're doing is they're taking someone else's content, and they would argue they're doing a transformative use of the underlying asset, and that they're creating something new as a form of commentary. But you could also argue, especially if they're not adding very much to it, that they're just stealing the content. So you kind of get into the same arguments here. On the left, you have the SERP API. So SERP is an acronym. It's Search Engine Ranking something. Search Engine Ranking something. The idea being that it's incredibly valuable to know what your ranking is in Google, but they don't offer a very convenient API. And so you've had these companies that have come in, and you can see exactly what they're doing here. You create a search query, you tell a location, and you want to know, where do I rank in this area? Who's ranking above me? Which search terms are better? What are the map results for coffee? And so this is what Google's initial results might look like. And then the service they offer is they scrape that and make it very convenient for you to pull out the data points. So recently Google sued SERP API, and you can understand Google's point. They're not getting any or much revenue from this because in all likelihood, the way that SERP API is doing this, they're not actually bringing down the ads, and God only knows, how many times a given search result, which has now been scraped, may be used by subsequent parties, all without Google getting any share of that. Okay, so this is a gray area. In general, though, what we've found in court decisions is that you're on more solid ground if the data is publicly available and doesn't require a login. It's also really important to state that terms of service and EULA, end user license agreements, regularly claim things that are absolutely ridiculous. So as an example, for a long time, iTunes, I think they still do have a section in their end user license agreement that says you can't use it for making nuclear bombs. Which, hey, if I want to create a nuclear weapon with iTunes, I think I'm going to do it, Apple. I'm going to just do it. Okay? All right. So at a high level, what are we doing? We're going to have this continual process that loops on itself. And the reason it loops is because our access may get cut off because people may see that we're scraping, and then we need to reestablish access. They may change the website over time, make redesigns, changes, etc. And then we need to reanalyze, and then analysis allows us to extract. So access, analyze, extract. And believe me, I was trying to find an A word here for extract, could not find it. So I understand this is a little bit annoying. This is like the underpants gnomes in South Park, right? Where they have a three-phase plan. Phase 1, collect underpants. Phase 2, no one knows. Phase 3, profit, right? There's a lot to be filled in, and we're going to fill that in now. So access. Websites have different levels of defenses and awareness. So these can run the gamut. We'll talk a little bit more about them over time. Your best bet is to blend in with their normal traffic. Behavioral tells would be something like click-throughs of hundreds of pages of results. Well, typically users, they only take what's on the front page of Google, maybe the first 5 results, something like that. So that would be a tell. Doing thousands of searches per day. Repetitive, inhuman-like precision. So if you always click on the 450 by 500th pixel, that's unlikely. Humans have more slack in that. They have more slack time in terms of the cadence of things. So like you're not going to click every 1 second. You might, if you're going through and you know the website well, you might click on something every 0.7 seconds or 1.2 seconds. So there's going to be variability. So first, we want to blend in as best we can. And another way that we can blend in, and this is actually huge, we'll talk about it a little bit, is proxies. So proxies allow us to spread around our requests. So the idea would be you have your computer, you go through one of these intermediate proxies, so say a server in Indiana or Arizona or Michigan, and then they relay your response to your ultimate target, and as a result, it looks like the traffic is coming from all over instead of it coming from your house in California where you're pulling down terabytes of data in these requests. So let's talk about analyze first, the analysis portion. First, DevTools is clutch. We're going to talk a lot about this. You're going to see me using it shortly. This is just a reminder slide so that when you're reviewing things on your own, you know this. Scraping has a number of different dimensionalities that can make life easier or harder. So one I'm calling structure. The easiest is static HTML. This is what most of the web was up until the advent of Gmail. Gmail introduced the idea of a more dynamic desktop-like application where you are putting data in and out without page refreshes. So obviously that's more complex, so it involves more things to consider versus just pulling down all the results burned into the page. API calls. So if you're not doing static HTML, you're doing something dynamic, and you have to have API calls. So you have to have these network traffic requests when you click on an email in Gmail. So those could be either clear text, JSON, so well formatted, understandably named, meaning it's not minified and unobfuscated, or it could be none of those things. It could be encrypted as well, and then you have to figure out how does the JavaScript decrypt this. This can all be done. It's just additional measures. And then finally, anti-bot protection measures. So obviously, if there are none, life is good. We can start to get things like CAPTCHAs, for instance, and there are also levels of CAPTCHAs, but I don't want to put that here. There are some CAPTCHAs that are easy to pass. There are others that require you doing logic challenges. and rate limiting are examples of anti-bot measures. So let's start with a statically rendered page. These are less common these days. Gmail was the first big site, as I mentioned, that introduced Ajax. For a lot of you, you've probably never seen a web page this old or ugly, but this is what the web used to look like, and you would do a static page refresh every time you navigate anywhere else. The data is burned into the page on the server side, and what we want to do is we want to process the result to pull it out of the presentation. So out of the UI, it is in a HTML DOM, which I'll talk about in just a moment, and fetching and parsing tends to be pretty easy. All right, so we are going to be using this awesome website, webscraper.io. They've set up test sites. These test sites, they kind of conform to the different categories that we talked about. So like a static page where everything is burned in, dynamic pages. We're going to start with their static page example, open a new tab, and we're going to bring up the dev tools as well by hitting inspect. Yours may appear at the right. If you want to change where it is, you can pick the different docking options there. And we're going to talk quickly about the dev tools. This is such a golden, incredible tool. Like it's hard to overstate how good this is, this tool for just general purpose web development. Firefox's is also excellent. So I want to start with the network tab. We're going to look at all the network traffic that goes across. So we're going to refresh, and we're going to see a number of things. And this is ordered chronologically from the top. We're going to see that there's a document, some style sheets, so that affects the styling of the page, scripts, images, fonts, etc. Now, I'm going to cheat a little bit just in the interest of us moving faster. And I'm going to say, well, we know that this is all being done via the document. So we're interested in understanding the document. And this is going to help us actually to understand broader websites because I want you to have foundational knowledge. You could probably just take this website, paste it in, and ask Claude to scrape it. But if you do that and that's all you know, then you're entirely reliant on Claude. So we will eventually use LLMs to do this, but let's understand first. So this is our response. We get this text coming across. It's an HTML document, but it's a string fundamentally. And so what happens to the string is it's parsed. And it's parsed into something called a DOM, a document object model, which is a tree-like structure. And that's what gives HTML all of its hypertext abilities. So like making this a clickable link, or formatting it so there's a header along the top and different fonts and sizing and behaviors along the sides. Ooh, probably shouldn't have clicked that. It's my bad. So as we hover over different elements, we can see it highlighted. So for example, this is the body. As we go down, we can see this is the header up top. And there's also a really nice feature where if you hit here, you can select individual elements and you can find where exactly that is. So this is a header 2, which is within the Jumbotron div, which is part of the columns layout. Everything is hierarchical, is what I'm trying to express here. Other really valuable things are over here, we have the console, which will allow us to do arbitrary JavaScript. So for example, setting a value, and we're going to touch on this more in a moment. I think for the time being, this is all we're going to need, but all these tabs are absolutely golden. Okay, so let's take a look at what we have so far. Let's say we wanted to scrape computers, laptops. Like we said, we have something coming across the network. Let's understand it a little bit better. So we know everything is going to be in this HTML document. We can look at the preview here, and we can verify that. So it's really important to understand what you're going to be scraping. So what we're seeing here is a preview of if we just rendered this HTML, this is what we would get. And we can see we're missing things like styling, but we have a test site up here, we have computers, laptops. As we go down, we start to see things we might want to parse for. So like the price of a computer, its description, number of reviews, perhaps if it's in stock. And what this does is, as I scroll down, it just verifies to me that everything that I'm seeing up here when I scroll through is already present in this document, which is awesome because we know we're in our first case where we're dealing with a static website. So what we're going to want to do is we're going to want to find ways to extract things like the price. To do so, it would be best to pull out each product, to think about this kind of, again, hierarchically. So we see there's an item prop called price, and we could grab just that, but we're interested in the price and the name of the thing as well. So as I scroll through, you can see that it has this structure, this hierarchical, where you have a div, and that div seems to encompass all of the item. And we're going to look for something that would be a convenient way to select all of the items. And I think product wrapper seems like a pretty good thing to select on. So let's take that, we'll copy it. And one of the great things about the DOM is it allows you to do selections on it. So we will do a get element I've been using Firefox tools a lot. Query selector all, and we need a selector. And we know this is a class. Classes are denoted with dot. Don't worry, your LLM can do all this for you if you need to. And what we're getting is, it's telling us down here, you'll notice that this is opaque. It's giving us a preview of what we would get if we were to execute this command. So you can see if I change the selector, all of a sudden it doesn't find anything. Now it finds 117 things. We can expand this, and we can open it in the elements, and we can bring into view if we wanted to, and we can see that we have in fact selected each one of these. So we got all 117 of these elements. Now what we want to do is we want to pull out specific things from it. So we will take, for example, the 0th element, and you can see it's really nice. It's highlighting it right now. And let's start to break this thing down and to understand what we want to pull out of it. So we'll look here, and we'll start just drilling down, and we can see, for example, if we wanted to get the aggregate ratings, we could get it via the item prop. So let's go ahead, and rather than that, let's say we're interested in the pricing. So what we can see is there's an item prop called with the value of price. So let's go ahead, let's go over here. And I did a little bit of cleanup off camera, a little movie magic there. We're going to name this products. So products will have our 117 items. And then if we want to, for a given product, say product 0, get out that value, we are going to do a span, because that's what it was, item prop equals, oops, forgot quotes, sorry about that, equals price, close that off, close that off, and what we can see is we get back a span with the price. If we were to do text content, tab it out, we see it's $295. Perfect. So if we were to apply this to all the products on the page, we could get all the prices, all the review counts, the descriptions, etc. Okay, so we've kind of established this. So now we're going to take this over into, I'm using Cursor. You guys can certainly use Claude Code though. The reason I'm using Cursor is just I want to have more of an emphasis on the code as we're learning. So I will create a new session, new chat here. I'm going to say, have a web page with this structure. Let's go ahead, let's grab the structure from the networking tab. If we go under the responses, we could grab this, or by grab this, I mean we could do a copy and a paste on all this, but it's a little nicer to get the entire structure. So let's go ahead, edit it as HTML, we'll copy, we'll paste. I understand this is very manual, but it's worth understanding what's going on. So scrape.html, throw it in there. We'll reference it. I want to pull prices, product names, and review counts. And since we know that this is a very simple example, we're going to use simple tools, use HTTPX and beautiful soup. And we're going to let it run. So I'm reminded of when I was taking calculus for the first time. If you've ever learned the simple trick of how to do derivations and how to do derivatives, it's really frustrating having to do the limit version. You're like, why can't I just go to the final step? And the reason is because you want to understand the fundamentals of what's going on, and then you can do the trick. So we're going to let this run. And again, you could probably just take the URL, throw it in here and say scrape HTTP : and it would probably work. So let's see what we need to do here. We need to install our dependencies. Let's go ahead, do that. That's probably fine. Keep the file, and let's run it. And that looks pretty good. We can see we got, it looks like all 117, they were saved into product.json. Let's take a look at that. Beautiful. I was reviewing the code off camera just because I didn't want to eat into our time. We only get about 45 minutes for each of our lectures. And I noticed something funny, which is, so this is the main file. It's actually taking the HTML file and it's scraping based off of that. If it doesn't find the file, it returns. It does nothing. So obviously, this is not what we wanted. It does, however, have a scrape from URL, which makes sense. But when we look at the references, it's not being used. So this is one of the downsides of AI coding, is if you don't know what's going on, you can get a very sensible result. So in this case, I was pulling everything as of the moment that I scraped from the file. But if this were a dynamic site, which was actually changing, I would just continue to get the same results and I wouldn't notice. So I realize I seem like a dinosaur when I'm saying we should be looking at the code, but this is the reason why. So we're going to ask it to clean things up. I'm going to say I want it to always pull from the website, use a default of, and I'm realizing this is also kind of my fault because I didn't provide it with a URL. I just provided it with HTML. And so it couldn't reasonably know what the URL is. That said, it really should have prompted me. All right, so let's have this chug along and let's have it make it dynamic, and then let's try once more. While we're waiting and while this is chugging, I'll talk about the next steps. So we have a default URL I can see showing up here. We can also take from the command line, it seems like. That's good. So the next steps are we're going to examine the more difficult cases, but now that we understand that we're just writing selectors, let's keep the whole file, let's assume it's good, and let's run it. It says it's saved to product.csv. Let's toss both of these just to be sure, and scrape.html. Let's hook up a debugger, and we will debug Let's see, so I need to, they've made it so hard to do real development in this. Okay, perfect. We have our debugger set up, we have our breakpoint. We are going to, really? There we go, debug. And we're going to step through and just make sure we understand exactly what it's doing. Okay, we're using the scrape from URL. We're going to step in. This is going to reach across the network. HTTPX is an HTTP client. It's going to call this URL. We'll get a response back. Cool, we can see we got a website. That looks good. We're going to extract from that website's text. Beautiful Soup is an HTML parser. As you go through, you can see, for example, we're pulling out the price element here based off a span with an item prop. So it came to the same conclusions we did in terms of the selectors that should be present, all the different product cards. Let's see, it does it based off of, so I don't actually like its selector as much for the product cards, but it's passable. I can certainly understand that. Let's make sure it gets a price element. Yeah, $295. Perfect. So I feel pretty good about this. We would want to, if we cared about this code, to review it in its entirety to make sure it was doing what we wanted it to. But that looks correct. Okay, so we saw the static case. Let's move on to a dynamic page. In this case, we're going to need a browser. Just pulling the HTML won't work because there's JavaScript. JavaScript provides interactivity and allows for a rich experience. That richness comes at the cost of complexity. Test frameworks tend to be very useful, things like Selenium and Playwright. And so the difference from the static case is the page renders, then the JavaScript runs. We may need to manipulate things to get the page in the state that we want, and then we perform the static page pull steps, meaning we scrape using query selectors. So let's go back to our e-commerce site, and we are going to try the infinite loading page. So let's open that up. Let's bring up our dev tools. I'm going to shift to the right side of the screen because this is an infinite scrolling page and it doesn't render particularly well. It's not very clear when we're loading more things if we have it taking up the vertical real estate. So we'll go under the laptops, and you can see as we scroll, more things are loaded. So we need this interactivity of scrolling in order to see all the results. Let's refresh, and I'll show you how we can do this in JavaScript. So first off, we have this query selector that we used before, where we're getting all the products. In this case, we find 3 of them. As we scroll, we find more. So now we have 6. There is a method called window.scrollby, and it takes an X and a Y. Here you can see in the prompt an X and a Y. So we want to scroll by Y 300 pixels, and that will bring us down to the bottom of the page. And obviously that's loading additional elements. So once we've done this, then we're back in the same regime that we were in before, where it was we can use our selectors to grab out all of the different elements. So what we need is we need a browser. And as we discussed, we can use something like Selenium or any of the Chromium-based browsers. Chromium is the open source version of Chrome, tend to be really good. We're going to skip right to using Selenium Base though. So what Selenium Base is it's a really nice way to avoid bot detection. So we could use the testing tools and then we would see, hey, on some sites we get caught because it's very obvious. Instead, we're going to just jump right to using this. So let's go over to Cursor and let's say using Selenium Base in presentation mode, I want to scrape this website, which has infinite scrolling. This may be more context than we need to provide it, but that's okay. Scroll until no new results come up, then scrape. And let's see what this gives us. We'll close some of our prior results here. Okay, we're going to need to do our pip install to bring in Selenium Base. Oh, this is unfortunate. It looks like it's overwriting our initial scraper. Oh well. Okay, it's running it, and it actually seems to be doing a pretty good job. This is not me, hands off right now. It's scrolling down. So the next thing we really want to see is we want to see that once we run out of results, once it no longer has anything additional loading as it does the scroll down actions, then it should understand that it's time to go into the scraping step. Selenium Base, while we're waiting on this to finish, what it's doing is it spins up a browser, and the browser is it kind of lives on its own, and it uses this thing called CDP, Chrome DevTools Protocol, which allows it to connect to the browser occasionally, but not be there all the time, and as a result, it's less detectable than other methods, because it really is just a standalone browser for most of the time, and then occasionally we connect, we perform some action, and then we release it. Okay, so it looks like maybe we didn't get everything we wanted out of that, and so it's going back through. It's doing another scrape of it. While it's doing this, I will say there's an absolutely excellent series of docs in Selenium Base. This is where I've learned most of what I know about kind of maintaining undetectability and being able to scrape popular commercial sites which have CAPTCHAs and things like that. This guy, Michael Mintz, you should hope that in your life you find something you love as much as he loves scraping. So let's, brought me back here. It's still struggling, so while it does, I'll give his YouTube a quick shout out here. So it is Michael Mintz, and all this guy does is look at scraping and talk about scraping and how to remain stealthy and bypass CAPTCHAs. Absolutely fantastic, the work that he's doing. Okay, so let's take a look at where we got. Let's run this. It spins up the browser. It begins doing its scrolling through. Down here, we can see the progress. I'm going to speed this up. All right, it saves it off into this product.csv, which looks correct. Perfect. So we were able to scrape a dynamic page. Okay, so final thoughts, anti-bot protection measures. We didn't talk a whole lot about this, and in general, I would say just leave this to third-party libraries and other people to implement, because this is a huge cat and mouse game. You have to really understand exactly what's going on the defender side, the ways that they're detecting and fingerprinting things, and it's a constantly moving field. So the best bet is pick a framework like Selenium Base or Scrapeling. There are many of these, and essentially they're all doing what we talked about with the CDP driver, where they disconnect so that it's pretty much indistinguishable from a normal browser. What the defenders are doing is they're constantly looking for any kind of fingerprint, any kind of unusual behavior, so that they can distinguish what they view to be illegitimate traffic from normal users. they'd prefer not to hassle you with CAPTCHAs because, and their preference and general disposition is not to use CAPTCHAs. The reason is because when you're presented with a CAPTCHA like this, one, it's incredibly annoying for the user experience. Two, it impacts their conversion rates tremendously. So their bias is towards not presenting the CAPTCHA. And if they do, they might present a simpler CAPTCHA than this. This is a logic puzzle, which is really hard to read. And sometimes I can't even read these. So we have that going for us. The other thing is it's almost unavoidable. You're going to need to use proxies just because if you are scraping a website every day, multiple times, pulling huge amounts of data, eventually they're going to see, hey, who is this one IP that constantly keeps hitting us? And they're going to block you. And then we get into proxies. There are different kinds of proxies. You can get data center proxies, so something like AWS or some other provider. The issue there is it's coming from a set of IPs that are probably known to be belonging to AWS or some other provider. Residential proxies get super gray. Maybe they're not botnets. I don't know. But whenever I've looked and tried to understand how these come into existence, it always seems incredibly shady. It seems like something where, hey, it's a bunch of grandmothers across the globe that all got hacked and now they're routing traffic through. Whether you choose to use those or not is entirely up to you. All right, so that gave you a rough understanding of scraping, the scraping landscape. I hope you enjoyed it. If you have any questions, I'm available online or in person.